Hello friends, welcome back. In this video, we are going to discuss about the different resources which we have into the Kubernetes and understand about that. Okay, so in this video, we'll cover the pod as a resource and how exactly it functions. Below are the resources: namespace, pod, replica set, jobs, cron job, daemon set, stateful set, deployment, service, endpoint, ingress, config map, secret, persistent volume claim, storage class, service accounts, and the RBAC. RBAC stands for role-based access control. Okay. Now, if you remember in our previous video, we discussed about what is Kubernetes, right? And what problem it solves. Okay. The difference between the virtualization and how the journey came till Kubernetes and what exactly the value add which Kubernetes is bringing. In this specific video, I would like to focus majorly onto the why Kubernetes, right? So container management is very hard, okay? Because if you see, containerization is not the easy one, okay? It's a complex one, okay? So management of the container is very hard. It's error prone and the annoying. Manual deployment of containers on the production environment is very difficult, okay? Because we need to like basically maintain the life cycle of the containers, create the container, deploy the containers, right? And then destroy and then recreate the one. So we should have some platform where we can manage these containers and their respective deployment. Container might go down and needs to be replaced, right? So as we understand in our previous stuff, that containers are not like a long lived, okay? It is meant to be kind of a destroyable entity, and then it can be recreated, okay? So container might go down and needs to be replaced with the new changes. If the traffic increases, we might need more container, right? So as of now, let's say I can have one container, but if the traffic increases in a specific time period, then I need to increase the number of containers. Okay. Third point is the incoming traffic needs to be distributed equally. Okay. So because of that, we need to really maintain the traffic. Like, okay, which container will receive the traffic depending on the capacity, CPU, memory, right? And depending on the customer base, I need to really manage that capacity. So it's not that much easy. So that's the reason we need a Kubernetes. So why Kubernetes? Because it manages the container lifecycle end to end, and basically not only management but the basically the infrastructure around that as well. Okay, so that is very important. In case of AWS ECS, we have basically a container service. Okay, AWS ECS can help here, but that is a cloud locking. Okay, and we need to learn this ECS. So if you see in case of the AWS, ECS provides the container service. Okay, but it is a cloud locking, because then if we start using the AWS ECS, then our entire workload is a AWS compatible. Compatible in the sense we are like a cloud locked. Okay, okay, so we need to only use the AWS services and then deploy onto their infrastructures and all that, right? So it is not like a cloud agnostic kind of way. Okay, so that is the case. So point here is basically ECS gives the service, okay, and we need to understand on that. Okay, so that is one point. Second point is uh, we have basically Kubernetes, which comes as a de facto standard for orchestrating the container deployment. Okay, automatic deployment, management, scaling, and load balancing. Okay, so Kubernetes does all this stuff. Okay, in a in a very stable manner. Okay, now another point is what is Kubernetes is and what is it's not. Okay, so there are many, as I understand, and as I mentioned in the previous video also, there are many misunderstandings about the Kubernetes, which I also cleared. So what is Kubernetes and what is it not? It is not a cloud service provider. Okay, it is not alternative to the Docker container. It is not. Okay, so we are not changing anything related to the Docker container, right? It is a collection of a software and tools which can be deployed on any machine. Okay, and it is a open source project. Okay, so developed by the Google, and that is the case. So this is all about the Kubernetes and why Kubernetes is very important. Now, basic difference which I would like to mention here about the responsibility. Okay, in this slide, I would like to mention about what Kubernetes will work and what is your work. Your work in the sense, the responsibility of the actual admin or maybe the our responsibility, right? And what Kubernetes will work. Kubernetes will manage the containerized application through running containers in a pod. Okay, that is the job of the Kubernetes. And what is our job, or what is like basically the user's job? Create the cluster, worker, and the master node, right? So Kubernetes will manage the containerized application, but the creation of the entire infrastructure, worker node, and the master node, and the associated components in that, it is a responsibility of the user or the admin. Second point, Kubernetes will not manage the infrastructure for you. Okay, so it is not some Kubernetes is not like a something infrastructure management tool. It is not. It is not a cloud infrastructure provider that we already saw and discussed. It is not even a cloud provisioning tool. Okay, so Kubernetes will not manage the infrastructure. It is not an infrastructure management tool. Okay, so in this point, what exactly we need to do? We need to set up the APIs, kubelet, and other services onto the node, right? So as I mentioned earlier, the client components and the master components, which we need to manage properly. That's it. Okay. And other point is, apart from once the cluster is up and running, then we need to create the resources like load balancers, network resources, right? And then basically we need to apply the security policies as well, okay, so that our cluster is like a secured, and then entire workload is properly secured, right? So that's how it works. Okay, so this is the basic difference which I would like to mention here, and make it more clear and the understanding that what exactly Kubernetes will work and what a user will work. Okay, that's how it is. Okay, now let's start with the basic one about the pod, right? Now, what is a pod? Okay, pod is the smallest deployment or a deployable unit. Okay, it is the smallest deployable unit in the Kubernetes. It can be created or destroyed. Okay, it is basically a deployable unit. Okay, in a pod we have a containers. It can be a one container or a multiple containers. Okay, so pod can contain a single container or a multiple container. Okay, it can be created and then destroyed. Okay, so it is not something like a permanent kind of a object. No. Okay, so whenever there is a like some issue, or maybe whenever there is an update, pod can be created and pod can be destroyed. It is a group of one or more containers with shared storage and the network resources, right? So the basically all the containers inside the pod, okay, they share the same storage and the network resources, right? Now there is a pod spec, okay, so there is a YAML file, okay, and then using this spec we can create the pod. Okay, so if you see, there is a certain spec, nothing but the specifications which I have mentioned here, and then using that specification we can create the pod. Okay, so there is a specific syntax for that. Okay, and then you can go ahead and then create this YAML file with this content, and then create the pod using this content, right? Typically we don't create pods directly. Okay, so pods should not be created directly. Okay, I mean we can create the pods using this YAML file, right? Because if you write the YAML file and with this content you can create the pods. Okay, but ideally, okay, pods should be created or gets created through deployment or job. Now what is a deployment and what is a job, we'll see later in our like a later videos. Now, pods can be used in a two ways. Pods that run in a single container and pods that run in a multiple container. Okay. So in one container, one pod model. So there are two models, like multiple containers in a one pod and one container in a one pod, right? So in one container, one pod model, most common and recommended way to use pods in a Kubernetes. It is a one-to-one relationship. Okay, single instance of a given application, right? So let's say if I have a small application, let's say web application, and that web application is deployed into the one container, and that container is deployed into the pod. It's a one-to-one mapping. Okay, and it is a single instance of the given application. If application needs to support more load, it can be scaled horizontally. That is a replication. Okay, so we will replicate. Okay, and then more load can be sufficed. Now, in the other model, there is a multiple correlated containers, okay, per pod. which share the same resources. Okay, that is a little bit onto the advanced side. Okay, advanced topic. Apart from that, you cannot add additional containers in the existing pod. So once the pod is in a running state, okay, then you cannot add additional containers in the running pod or in the existing pod. Okay, so if you have to create, if you want to create the more pods, sorry, more containers in a pod, then you need to like stop the pod or maybe recreate the pod with the additional set of the containers. Okay. Now, this node name property, there is a property called node name, which is used to schedule the pod on a specific node. How the pod gets scheduled on a specific node, that is a there is a node name property. Okay, that we will see actually into the practicals in our subsequent videos. Okay, so that is the case. Now, pods and controllers. Okay, now there are certain things which I would like to skip here. Okay, uh, this is not something related to the basic. Once we start with some kind of a maybe advanced course, then we'll come back to the slide and then understand more. Okay, so point here is like the basics about the pod we understood. Okay, and then now let's understand about the basically how exactly the communication works, okay, in the pod. Now, if you see in this diagram, okay, there is a external IP 10.1.1.1, okay, and that specific IP is assigned to some external like a machine or maybe some identity, right? Now, what happens, right? If you see here in this pod, I have a containers. I have a two containers, right? One container is running on 1000 port and another container is running onto the 2000 port. Okay. So how it connects? So basically, as I mentioned earlier, right, in this pod, the pod gets connected onto this 2000 port. Okay. So whenever user use the 1000 port, okay, and the IP address combination, then it will go to the container one. And when it uses the 2000 port, okay, and the combination of the IP address, okay, then it will go to the container two. Okay, so in a given pod, I can have two containers which are working on a two different basically ports. Okay, and then you can communicate to that specific application which is running inside that container. Okay, so this is how basically a simple diagram which explains the functionality of the pod. Okay, so there is a pod, okay, and pod has a specific unique IP address, right? Every unique IP address is there. Now, if I have to access the container one on 1000 port, that port is mapped to the IP address of the pod, and then I can access the application using that container port. If I have to access the application into the 2000 port of the container 2, then I will access the pod's IP address and then the 2000 port, and then using that specific route, I will access the application which is running inside the container 2. Okay, so this is how the actual pod functions. Okay, so I hope you understand like what is pod and how exactly it works, and then how many containers are there, how the relationship is there, and how they get assigned the workload, and how we can access the application inside the container, right? I hope you like this video, and then please subscribe to this channel, and then we can continue with the other set of videos. Yep. Okay, thank you.